multiple choice question on algebra. The first example, find modulus and argument of complex number z is equal to 1 plus I divided by 1 minus I. So first of all, we want to write this complex number in standard form. So the given complex number is 1 plus I divided by 1 minus I. So if you multiply by denominator complex number by its complex conjugate, then it is 1 plus I divided by 1 plus I. So this is equal to 1 plus I bracket square divided by, now it is a minus b and a plus b, which is equal to a square. This is equal to a square minus b square. So this is equal to 1 square minus iota square. Now 1 plus I square is equal to 1 plus 2I plus I square divided by 1 minus I square is minus 1. So it is equal to 1 plus 2I plus I square is minus 1 divided by 2. So this plus 1 minus 1 will get cancelled here, and it is 2I divided by 2, which is equal to I. So the given complex number z is equal to I. That is, we write the given complex number in standard form. Now if we represent this complex number I on the on complex plane, say here 1 minus 1 I minus I. So the distance of this complex number from origin is 1. So the modulus is equal to, that is mod z is equal to under root of real part square plus imaginary part square. So this is 0 square plus 1 square, which is equal to 1, or you can observe here the modulus is 1 and argument is equal to angle made with respect to positive x-axis, which is equal to pi by 2. So here theta, that is argument of the given complex number, is equal to pi by 2. Now next find the values of say 156 modulo 9. So if you divide 156 by 9, then it is equal to so here 6 again, and 9 times 7 is 63. So it is equal to what? The remainder is equal to what? 3. That is 156 is equal to 9 into 17 plus 3. So here the remainder is equal to 3, and therefore 9 into 17 plus 3 is equal to 156. Okay, so here 156 congruent to 3 modulo 9. So the answer is what? 3. Now next find the remainder when 2 raised to 30. Find remainder when 2 raised to 20 plus 2 raised to 30, 3 raised to 30 is divided by 7. So we want to determine what is the remainder. Again, by using Fermat's theorem, if P does not divide A and P is a prime, then A raised to P minus 1 congruent to 1 modulo P, and hence here, since 7 does not divide 2, this implies 2 raised to 6 7 minus 1 congruent to 1 modulo 7. So this is equal to 2 raised to 6. This implies 2 raised to 6 congruent to 1 modulo 7. Now next, again since we want to determine power of 2 raised to 20, here we obtain 2 raised to 6. If we take, again we know that a raised to n congruence to b raised to n modulo say m. By using this property we can write 2 raised to 6 raised to 3 congruence to 1 raised to 3 modulo 7. So by using this property we can write this as 2 raised to 18 congruent to 2 raised to 18 congruent to 1 modulo 7. But since we want 2 raised to 20 from this, and again 2 raised to 2, that is 4 congruent to 4 modulo 7, by using these two equation we can write 2 raised to 20 congruent to 4 modulo 7. If you multiply this, then we get 2 raised to 20 congruent to 4 modulo 7. So 2 raised to 20 congruent to 4 modulo 7. Next, similarly, the same logic we are going to apply. Since 7 does not divide 3, this implies, by using Fermat's theorem, 3 raised to 6 congruent to 1 modulo 7, and this implies, okay, now we want 3 raised to 30 power, 3 raised to 30, and we reach up to 3 raised to 6. So if we take here 3 raised to 6 raised to 5, then it is congruent to 1 raised to 5 modulo 7. So this is equal to 3 raised to 30 congruent to 1 modulo 7. So this implies so, and 2 raised to 20 congruence to 4 modulo 7. So if you add these two equation, then we get 2 raised to 20 plus 3 raised to 30 congruence to 5 modulo 7. So when we divide this 2 raised to 20 by 3 raised to 30, remainder is equal to what? 7. Now the next question is find an element. Okay, we know that again in Z6 is equal to 0 bar, all the equivalence classes modulo 6, so it is 0 bar, 1 bar, 2 bar, 3 bar, 4 bar and 5 bar. Then here 0 bar square is equal to 0 bar, 1 bar square is equal to 1 bar, 2 bar square is equal to 4 bar, which is nothing but the 4 bar, and 3 bar square, which is equal to 9 bar, and 9 bar is nothing but 9 bar, which is equal to again 3 bar. So 3 bar square is equal to what? 3 bar. Next, 4 bar square is equal to 16, and which is congruent to, if we divide 16 by 6, then again it is equal to what? It is equal to 4 bar, and 4 bar square is equal to 4 bar, and 5 bar square is equal to, it is 25 congruent to 1 bar. So 2 bar, 4 bar square is 16, yes, it is what? 4 bar. So this is all about the Z6. Then find, next question is find domain and range of function y is equal to x square plus 2. Now again this function is defined for every values of x. So here domain is equal to a real number, and range we know that since y equal to, this is the graph of y equal to x square, so the graph of y equal to x square plus 2, we want to shift this graph up by 2 units. So the graph of, this is the graph of y equal to x square plus 2. So the range is 2 to infinity. So range is equal to 2 to infinity. So domain is R and range is equal to 2 to infinity. by using this. You can see here the x-axis represent domain, so this function is defined everywhere, so domain is R, and the range y-axis represent range, so y is equal to 2 to infinity. Now next find the complex number. Find the complex number, say find the multiplication of two complex number 3 1 and 5 2. Okay, we want to determine the multiplication of this complex number. That is, the first complex number is 3 plus 5i, and the second complex number 3 plus i iota, and the second complex number is 5 plus 2 iota. So it is equal to, so we know that the multiplication of this complex number is 15 minus 2 into 2 and 6 plus 5. Okay, so the multiplication of this complex number is equal to 13 and 11, and in other words 3 plus I into 5 plus 2i is equal to 15 plus, if you multiply this 3 to this bracket, this is 15 plus 6i plus 5i plus 2i square, so this is equal to 15 plus 11i minus 2, I square is equal to 2, so this is 15 minus 2, it is 13 plus 11i. So if you write this into that is in this form, if we write this into in this form, AB form, then this is equal to 13 and 11. Now next find the value of complex number I plus I square plus I cube plus I raised to 4 plus I raised to 5 plus I raised to 6 plus I raised to 100. We know that I is equal to I square is equal to minus 1, I cube is equal to minus I, and I raised to 4 is equal to 1. And so if we add the first four terms, that is, if we add I plus I square plus I cube plus I raised to 4, then it is equal to I minus 1 minus I plus 1. So this plus 1 minus 1 get cancelled here, plus I minus I get cancelled here, so this is equal to 0. Again, if we add similarly next four terms, so if we add the successive four terms, then their addition is equal to 4, and we know that similarly I raised to 97 plus I raised to 98 plus I raised to 99 plus I raised to 100. So this the last pair, value of the last pair is equal to also what? 0. So the value of this addition is equal to, total addition is equal to what? 0. And because 100 divides 4, so there are how many terms of four terms? That is, if we know that 100, if we divide 100 by 4, then this is equal to 25. So there are 25 such terms whose their addition is equal to what? 0. So 25 times 0, and their addition is equal to what? Again 0. But if you add here I raised to 101, then the sum of this term is equal to what? I. So next find the modulus and argument of complex number 1 minus I times under root 3. So we know that if you compare this complex number, z is equal to x plus iy, then this is equal to modulus of z is equal to square root of x square plus y square. So the modulus of z is equal to, mod of z is equal to square root of 1 square plus under root 3 square. Okay, so this is equal to 1 plus 3, which is equal to under root 4, and which is equal to what? 2. So modulus is equal to 2. Now we want to determine argument. Now this complex number lies in the x is positive, y is negative, that is here imaginary part is negative, so it lie in fourth quadrant. So the angle is equal to argument of z is equal to minus tan inverse of absolute mod of y by x. So argument of z is equal to arg of z is equal to theta is equal to minus times tan inverse of modulus of y by x. So y is equal to here x real part is 1 and the imaginary part is equal to minus square root 3, but modulus is always positive, so it is equal to 1 by root 3. This is equal to minus tan inverse of 1 by root 3, and which is equal to minus pi by 6. Tan inverse of 1 by root 3 is equal to pi by 6. Now next, consider an relation defined on consider relation on set x defined on set x such that for any elements a b from set x, a related to b if and only if a is less than b, check whether R is reflexive or equivalence relation. Check whether R is equivalence relation. Now we know that for any real number, first we are going to check whether given set is reflexive. Now 2 is not less than 2, or in other words, or since a is not less than a, this is not true, that is a is less than or equal to a, so a is not related to a for every a in set x, and therefore given relation is not reflexive. Then next, symmetric. Now if a related to b implies a less than b, but a less than b, but this does not imply a is greater than b, that is, this does not imply b also related to a, that is, we know that since 2 less than 5, this implies 2 related to 5, but since 5 is not less than 2, and therefore 5 does not related to 2, and hence given relation is also not symmetric. It is not symmetric. Next, we are going to check whether it is transitive relation. Now if a related to b and b related to c, then a less than b and b less than c. So if you combine these two equation inequality, we get a also less than c. A is also less than c, and therefore this implies a related to c. That is, if we combine these two equations, a less than b and b less than c implies a less than c, and therefore a related to c implies R is transitive relation. Now it is not reflexive, not symmetric, but transitive, so this is not an equivalence relation. So thank you.